Hello future engineers, welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends, to your younger brothers and sisters who would want to take up engineering in the future, and to your relatives. That's one way you can keep me going, inspired and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. So here is Vitamath 65 about sketching curves. So sketch the graph of f of x equals absolute value of x squared minus 4 times absolute value of x plus 3. So for negative infinity to 0, or for x which is negative, remember that absolute value of x is always positive. So if x is negative, then absolute value of x is negative of x, because x is negative in this interval. So for instance, if x is negative 5, negative of negative 5, so that makes it positive. Absolute value of negative 10 is negative of negative 10, so it is positive 10. So therefore, we transform this, or we plot x squared minus 4 times negative x, so it becomes 4 plus x plus 3. So it's the same as plotting absolute value of x squared plus 4x plus 3 in this interval. So let's plot it by point plotting. So we have x and f of x. We begin with negative infinity. So for instance, negative 100 square plus 4 times negative 100. Negative 100 square is 10,000 minus 400, so 9,600 plus 3. So it's infinity in general. It's positive infinity. So negative infinity, f of x is positive infinity. Then when x is negative 5 square is 25, plus 4 times negative 5 is 5, plus 3, 8. Absolute value of 8 is 8. So x is negative 5, f of x is 8. When x is negative 4 square is 16, plus 4 times negative 4, 0, plus 3, so it's 3. Negative 4, f of x is 3. When x is negative 3 square is 9, plus 4 times negative 3, negative 3 plus 3, 0. So negative 3, f of x is 0. When x is negative 2 square is 4, plus 4 times negative 2, negative 4 plus 3, negative 1. Absolute value of negative 1 is positive 1. So negative 2, positive 1. When x is negative 1 square is 1, plus 4 times negative 1, negative 3 plus 3, 0. So negative 1, f of x is 0. Finally, when x is 0, 0, 3, absolute value of 3 is 3. So let's locate these points on the graph. Then let's have first negative 5 and 8. X is negative 5, then 8 as shown. Then negative 4, 3, negative 4, positive 3 here. Then negative 3, 0 here. Negative 2, negative 2, positive 1. Then negative 1, 0. Then 0, 3. So for accurateness of the graph, although we have negative infinity, positive infinity somewhere here, so the graph rises when x is decreasing without bound here. And to make sure that the graph is accurate, let's insert intermediate points like negative 4.5, substitute there. Negative 3.5 rather here. Then f of x, substitute here, then use your calculator to evaluate that. Remember that this is always positive, so it's 1.25 as shown here. When x is negative 2.5, negative 2.5 square is 6.25 plus 4 times negative 2.5 is negative 10. Negative 10 plus 6.25, 3.70, negative 3.75 plus 3, negative 0.75. And absolute value of negative 0.75 is positive 0.75. When x is negative 1.5, it's there. Negative 1.5, negative 1.5 square 2.25 plus 4 times negative 1.5, so negative 6. So again, negative 3.75 plus 3, negative 0.75, absolute value of points, negative 0.75. 2.25 minus 6 is 3. 2.25 minus 6 is negative 3.75 plus 3, negative 0.75. So its absolute value of negative 0.75 is 0.75. Then negative 0.5, when x is negative 0.5, so it's here, negative 1.5 comma 0.75. When x is negative 0.5, so 0.25 minus 1, negative 0.25 minus 2, negative 1.75 plus 3, 1.25. Absolute value of 1.25 is 1.25. So let's insert negative 0.5, then 1.25. So the graph can now be plotted, can now be sketched as shown. So that's it. Then let's also plot from 0 to positive infinity. Then absolute value of x for 0 to positive infinity is just x, because this is positive, so therefore it is just x. So any value of x which is positive will just give us absolute value of that positive is just x here. So therefore we just replace absolute value of x by x for this interval. So we plot f of x equals absolute value of x squared minus 4x plus 3. So we have the same points to establish. So we begin with 0. When x is 0, it's 3. Absolute value of 3 is 3. When x is 1, 1 squared minus 4, negative 3 plus 3, 0. So 1, 0. When x is 2, 2 squared minus 4 times 2, negative 4 plus 3, negative 1. Absolute value of negative 1 is 1. So 2, 1. When x is 3, 3 squared, 9 minus 4 times 3, negative 3 plus 3, 0. So 3, 0. When x is 4, 4 squared minus 4 times 4, 0 plus 3, so it's 3. When x is 5, 25 minus 4 times 5, 5 plus 3, 8. And when x is positive infinity, so let's consider 100. Again, 100 minus 100 square is 10,000 minus 4 times 100, 9,600 plus 3, 9,603. Or when x is positive infinity, f of x is also positive infinity. So we notice that these points correspondingly at the same distance from the y-axis have the same y coordinate. So we expect that the graph is symmetric with respect to the y-axis. But let's insert intermediate points like 0.5. So let's plot first 1, 0, 2, 1, 3, 0, 4, 3 here, and 5, 8 there. then positive infinity, positive infinity. Let's insert intermediate points like zero point 0.5. So it is 1.25 if you substitute here. 1.5, so zero point 0.5, 1.25. 1.5, it's 0.75. So here, then 2.5, 0.75 here, then 3.5, 1.25. It's here. So if we sketch the curve, it is really symmetric with respect to the y-axis as shown. So that's it, and there will be sketching in more sketching techniques in calculus, including the location of maximum value, the slope of tangents to the curves, and that will be in future problems in Vitamath. So I hope that you enjoyed watching and you learn techniques again of sketching curves, especially for this rare function involving absolute values.